Next, let's discuss how can we convert this galvanometer to ammeter. Even though a galvanometer cannot be used to measure the current in a circuit, usually we use ammeter for that purpose. With some modifications, we can use or we can make galvanometer as ammeter. Okay, galvanometer can also serve the purpose of ammeter but with certain modifications. So what is that? If we want to convert a galvanometer to ammeter, what we want to do is, suppose this is the galvanometer and this galvanometer is to be converted to ammeter. So the first step is to connect a shunt resistance, a very low value of resistance in parallel to this galvanometer. So this resistance is shunt resistance, hence we can name that resistance as S. So by connecting a very low value of shunt resistance in parallel to the galvanometer, we can convert the galvanometer G to an ammeter. Galvanometer is usually represented by the symbol G. Okay, so what happens? Current I flows through the circuit. On reaching here, current divides into two. A portion of the current flows through the galvanometer and let that current be IG. So IG represents the current flowing through the galvanometer. Then the remaining portion flows through the resistance S. What will be the current? Total current is I, and what is the remaining portion? I minus IG. So I minus IG current flows through the resistance S, shunt resistance S. Now apply Kirchhoff's law to this loop. Whenever you apply Kirchhoff's law to this loop, we can follow in this way, in the clockwise direction. So when we follow this path, current IG and our direction is same. So we can write minus IG into G. We are applying Kirchhoff's voltage rule here. So minus IG into G, because the resistance of galvanometer is G. So when the current IG flows through the galvanometer G with a resistance G, the resistance of galvanometer is also denoted by G itself. What is the potential drop produced? Current into voltage. Current is IG and resistance is G. So the potential drop is IG into G, and it will be minus because we follow the same path of the current. Minus IGG, then we come in this way, move in this way, and then we proceed in this manner. So we can see current I minus IG is coming in the opposite direction. So when I minus IG flows through the resistance S, another voltage drop is produced. And what will be that voltage drop? I minus IG into S. And that will be positive because our direction and the direction of current is opposite. So we can write plus I minus IG into, this is the current and this current is flowing through the resistance S. So I minus IG into S is the potential drop. It will be equal to 0. And rearranging this, we will get I minus IG into S is equal to IG into G. Then we need to find out the value of this S. What will be S? S is equal to IG into G divided by I minus IG. So this is the value to find out the value of the, or this is the expression to find out the value of the shunt resistance that is to be connected in parallel with the galvanometer in order to convert it into ammeter. And do you know why do we need to connect a low value resistance and that too in parallel with the galvanometer if you want it to convert it to ammeter? This is because when we compare galvanometer with that of ammeter, its resistance is high and an ideal ammeter should possess zero resistance. So if we want to make galvanometer to act as an ammeter, we should decrease its resistance. Then only it can act like an ammeter. It can serve the purpose of ammeter. And we can decrease the resistance of galvanometer by connecting a very low shunt resistance and that too in parallel with the galvanometer. But otherwise what will happen if we connect a shunt resistance in series with the galvanometer? What will happen? The overall resistance of the galvanometer will increase, because in a series connection the total resistance will increase. In a parallel connection the total resistance will decrease. And what will be the total resistance of this galvanometer now? The total resistance of this galvanometer, or the total resistance of this converted ammeter, will be 1 by total resistance or equivalent resistance will be 1 by G plus 1 by S. Okay, G is the galvanometer resistance and S is the shunt resistance, and this arrangement together constitute our ammeter. Galvanometer plus the shunt resistance constitute our ammeter. So the total resistance of that ammeter will be total resistance of that circuit, that will be 1 by G plus 1 by S, because G and S are connected in parallel. And if you do the cross multiplication, you will get, it will be equal to G plus S by GS, and that is 1 by R equivalent. So what will be R equivalent? R equivalent will be equal to GS by G plus S. So this is the G plus S. So this is the equivalent resistance of the total resistance of this ammeter. Okay, so a galvanometer can be converted to ammeter by connecting a very low shunt resistance in parallel with the galvanometer. And how will you find out that value of that shunt resistance? By using this expression, S is equal to IgG by I minus Ig, where Ig is the galvanometer current, G is the galvanometer resistance, and I is the range of that ammeter. Okay. Next, we can define the current sensitivity of a galvanometer. So what do you mean by current sensitivity? Current sensitivity of a galvanometer is defined as the deflection produced in the galvanometer when a unit current flows through it. Okay, deflection produced in a galvanometer when a unit current flows through it. We know that whenever current flows through a galvanometer, a deflection is produced, due to which a pointer attached to that galvanometer deflects. Okay, so or move. So next we can discuss about the current sensitivity of a galvanometer. What do you mean by current sensitivity of a galvanometer? It is defined as the deflection produced in the galvanometer when a unit current flows through it. You know that whenever current flows through a galvanometer, deflection is produced. And how much deflection is produced when unit current can be 1 ampere or 1 milliampere or 1 microampere. So whenever a unit current flows through it, how much deflection is produced? That measurement is obtained by calculating the current sensitivity of a galvanometer. And how will you find out the expression for that? It's very easy. We have already found out the expression for theta, or the deflection produced in a galvanometer. What is that? NAB by C into I. And just bring this I to LHS side. So we'll get theta by I is equal to NAB by C. Okay, so this theta by I ratio is the deflection. Theta is the deflection and I is the current. So theta by I, this ratio is deflection produced per unit current, and that is our current sensitivity S, and that is equal to, what is the expression? That is equal to NAB by C. So that is given here. Current sensitivity IS is equal to theta by I equal to NAB by C, where N is the number of turns and B is the magnetic field around the coil, A is the area of the coil, and C is the restoring torque per unit twist. So current sensitivity is NAB by C. How can you increase the current sensitivity? From this expression itself you can give the factors that is required to increase the current sensitivity. See here in this expression, NAB is in the numerator. So by increasing all the factors in the numerator, we can increase the current sensitivity. So when current sensitivity can be increased by increasing the number of turns of the coil, increasing the area of the coil, and also increasing the magnetic field At the same time, by decreasing the quantity in the denominator, we can increase the current sensitivity. So in the denominator, we have the restoring torque. So that by decreasing the restoring torque per unit twist, we can again increase the current sensitivity of a galvanometer.